Hello everyone, this is Mr. D'Agostino, Freeport High School. Hope everybody is doing well. This is Lesson 14 Startup. We are getting down to the last lesson. You know what that means, right? Review and then a test. Itinerary for today, do now problems. You're going to pause the video and do the problems on your own. When you are finished with the problems, unpause the video and watch me go over them. Number 2, Family Feud question of the day. Pause the video and write down answers. Unpause the video when you are ready to hear the answers. Number 3, go over previous lessons homework. Number 4, watch next lesson from eMath instruction. All right, you have 2 questions. If you do both of them, you get a 10.5. If you do the Family Feud, you get an 11. If you do one of them, you get a 10, with the option for the Family Feud to get an extra bonus point. All right, here we go. Number 44 for my regions file. And number 52 for my regions file. All right, pause the video and do the problems on your own. Unpause them when you're ready to go over them. All right, 44. It's an average rate of change problem, so you need to come up with outputs. Now, it says June 2012, June 2014, so that means it's 1 year after the car was purchased and then 3 years after the car is purchased. So I'm going to use V of t as my function notation because V is what we want, the value of the car that's depreciated. So let's see what we got here. I was using orange before. I kind of liked it, so I'm going to stick with orange. So V of t. So we need V of 1. We need V of 3. Now, if you plug a number in for t, how do you get V? The issue here is this is in log form. If you convert this to exponential, you'll be able to do that. So how do you convert log to exponential? You have to go to your old friend, Ben. Do you remember Benny form? Log base b of n is equal to e. That converts to b to the e equals n. So when you convert this, you get 0.8 to the t is equal to v over 17,000. Cross multiply, so you get 17,000 times 0.8 raised to the t equals v. Now you can plug 1 in for t, plug 3 in for t, and get your answers. I'm going to use the calculator. So I already punched it in, 17,000 times 0.8 raised to the x. I'm going to go to table. I'm going to do V of 1 first. V of 1 is 13,600, so I'm going to put that in. 13,600. I'm going to go back to the table and the calculator. What's V of 3? V of 3 is 8704. So 8704. Now, the way the average rate of change works, it's going to be the difference of the outputs over the difference of the inputs. So 8704 minus 13,600 over 3 minus 1. So now I'm going to go to my calculator, go back to the home screen. I'm going to use my alpha y equals button because I like that. So alpha y equals, pick number 1, 8704 minus 13,600 over 3 minus 1, which is 2. Hit enter, and I get negative, which basically means it's decreasing. You get negative 2,448, which basically rounds to, because it's nearest $10, 24.50. So negative 24.50 would be your answer for this one. I want to show you something else with the calculator. I don't know if you remember, I was doing this once before with function notation. We know that it's difference of the outputs. So V of 3 minus V of 1 over 3 minus 1. You can actually type that in the calculator just like that. But since we put it in y1, we got to use y of 1 is your function notation. So if I go back to home screen and I do alpha y equals, and I go to, I believe it's alpha trace. Yes, it is. I'm going to do y1, which is my function notation of 3, minus, go back to alpha trace 1 of 1 over 3 minus 1, which is 2. This should produce the same answer as what we just did, because what it's doing, it's taking y1, which is that equation that I put in, putting 3 in, getting an answer, putting 1 into that same equation, getting an answer, subtracting the 2. There you go. It's another way of doing it. So the answer is choice 3. All right, next question. Number 52. Which equation represents a parabola with a focus of 0, 4 and directrix of y equals 2? You're going to need the P formula. Actually, we called it P, actually, right? The P formula. Sometimes books call it, use A. We're going to just be consistent and use, I'm going to change that. Sorry about that. We're going to use P. We called it the P formula. All right, so there it is. X minus h in parentheses squared is equal to 4p times y minus k, where hk is going to be your vertex. Now, right now, we don't know what the vertex is. So I like to sketch a little graph of what this looks like. So let's use, what color you want to use? Let's use this one. I don't think I've ever used that one. It's like a teal. It's like a very light, subtle blue. All right, so I'm going to make a little x and y axes. I'm going to plot my directrix, which is right here, y equals 2. I'm going to graph plot my focus point, which is 1, 2, 3, 4. Now you remember how this works, right? Your turning point is equidistant between your focus and your directrix. So if my focus is 0, 4 and my directrix is y equals 2, my turning point has to be right in the middle, which is at 0, 3. So my vertex is at 0, 3. Now my P is the distance from my turning point, or my vertex, to either the focus or the directrix. It's because it's equidistant. That's 1. Now, another way to find P is you just figure out the distance from your directrix to your focus, and you just divide by 2. So it's 2 units from my directrix to my focus. Divide that by 2. So 2 divided by 2 is 1. So my P is 1. So I got my HK. I got my P, and now it's time to just plug it right into the form. I'm going to change this color because I don't really like it. I didn't really like that color. Let's go with purple. All right, so I'm going to plug in my vertex and my P. So x minus 0 in parentheses squared is equal to 4 times, look at that, there's your 1. 4 times 1 times y minus 3. So x minus 0 is x, so x squared is equal to 4 times y minus 3. Now you're taught to distribute, but when we were doing these problems, it was easier just to divide by 4 first. So now you have x to the second over 4. I'm going to bring the 3 over. Plus 3 is equal to y, and there's my equation. Looks like it's choice 4. All right, nice review on directrix and focus. We haven't done that in a while. All right, homework problems. But before we get to homework problems, we have our family feud. Let's see, family feud. This is what you guys like. 6 answers on the board. Name something parents tell their kids not to waste. 6 answers on the board. Name something parents tell their kids not to waste. All right, so I paused the video. I hear the answers. Hopefully you jotted down answers and you check the top answer. Here are the answers. Number 6, life. Okay, I don't know if you ever saw that movie, A Bronx Tale. It's a very good movie. Wasted talent. The worst thing that you can waste is talent, which is the same thing as life. Number 5, don't waste any time. Electricity. Make sure you turn those lights off. Don't waste any money. Don't waste water. And don't waste any food. That's from 6 down to 1. So life is 6, time is 5, electricity is 4, money is 3, water is 2, and food is 1. All right, there's your Family Feud question of the day. All right, let's go over the homework. All right, these are called solving rational inequalities. These problems were big in the old curriculum, Algebra 2, trigonometry, about 5-6 years ago. I haven't really seen it too much, but these are good problems to go over. Now, what you have to do is you have to come up with your roots, potential roots, or roots that could be part of your solution, could not be part of the solution, and then you have to use test points. Okay, now when you use a test point and it comes up positive, that means you shade in that direction. If it comes up negative, you don't shade in that direction. So how do you come up with roots? Now the first thing you're going to do is you're going to figure out what values make it undefined. So in this case, x plus 5, you set it equal to 0, you get x equals -5. So -5, anytime you come up with a number that makes it undefined, it's not part of the solution. That's why it's open circle on -5. And then whatever numbers you get in the numerator, okay, depending on your inequality symbol, see how this is greater than or equal to? That means that you're including that number. So x minus 10. Now, what I like to do is I just like to think of it as x minus 10. I'm using the mouse instead of my tablet here. X minus 10 is equal to 0. That's how I think about it. And that's x equals 10. So 10 is a possibility. Since it's a greater than or equal to symbol, it's included. So now your potential roots are -5 and 10, root 1 and root 2. Sometimes there's 3 roots. But whenever it's in the denominator, it's always open circle. Now the top part could be included, it could not be included, depending on the inequality symbol. Okay, in this case, it's greater than or equal to. Now what you do is you pick a test point. Test points say -8. You put -8 in. -8 minus 10 is a negative. -8 plus 5 is going to be negative. Negative divided by negative is positive. Now, is a positive number always going to be greater than or equal to 0? Yes. So that's true. So that's why it's shaded this way. Now you pick a number that's in between. Between -5 and 10, the best number to pick is 0. So you're going to use 0 as a test point. 0 minus 10 is a negative. 0 plus 5 is a positive. A negative divided by a positive is a negative. Is a negative greater than or equal to 0? No. So that means you don't shade in this area. So if it's false, you do not shade. Usually it follows a pattern. Sometimes it doesn't. Sometimes it does. But usually it does. So this is probably going to be shaded, but let's just double check it. Let's use 12. 12 minus 10 is positive. 12 plus 5 is positive. Positive divided by positive is a positive. So a positive is greater than or equal to 0. And that's how you do these problems. You got to come up with test points. Let's try number 2. Now, a potential root that's definitely not going to work because it'll make it 0 is -3. And then you take the top part and you set it equal to 0 and you solve. So this turns out to be -1/2. So -3 and -1/2 will go on your number line, and then you pick test points. Let's try -5. 2 times -5 is -10. -10 plus 1 is going to be a negative. And then negative 5 plus 3 is going to be a negative. So negative divided by negative is a positive. Now, is a positive less than 0? No. That's why you don't shade this area. Only a negative would be able to get a shaded area. So let's pick a number between negative 3 and negative a half. Let's pick negative 2. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So it's negative. Negative 2 plus 3 is a positive. Negative divided by positive is negative. And negative is less than 0. And like I said, sometimes this does follow a pattern. 0 is a good number to pick in this region to represent this area. So you get 1 over 3. A positive over a positive is a positive. And a positive is not less than 0, so that's why it's not shaded. All right, well, number 3. It turns out there are 2 numbers that make it undefined. So the best way to do these problems is to factor. So you factor the top, factor the bottom. These are what you get when you factor. So 2, negative 2, 5, and negative 4 are potential roots. So that's why they're all plotted here. Negative 4, negative 2, 2, and 5. Use test points. If it's positive, you shade it because a positive is greater than 0. If it's negative, you don't shade it. So that's why this gets shaded, that doesn't get shaded. This gets shaded, this doesn't get shaded, this gets shaded. Same thing with this problem. Factor the top, factor the bottom. 8, negative 2, 3, and negative 2. Since we already used negative 2, you just write it once. Then you use test points. Try negative 3. See what you get. We want something that's going to be less than 0. So you want something that's going to be negative. So if you get a negative, you shade it. If you get a positive, if you get a positive, you do not shade it. So positive, no shade. Positive, no shade. Negative, shade. Positive, no shade. So there's only one region that gives you a negative. And that's what we want. We want numbers that are going to be less than 0. All right, 5. Again, you factor the top, factor the bottom. Negative 3, you only write it once because it's the same factor here. This looks like it's negative 1 over 4, and this is 1. Pick regions. Pick numbers in that region and represent that, and you plug it in. So I'm going to put negative 4. Put negative 4 in. See what you get. Turns out you get a positive, which is what we want because we want a number that's greater than 0. So we want a positive number. This gives you positive. This gives you negative. That gives you positive. So this whole area gets shaded. This doesn't get shaded, and this gets shaded. All right, so you get the picture. That's pretty much what you had to do with this lesson. All right, now number 7. 7 is a little different because what they want you to do, it's not less than or equal to 0. It's not greater than or equal to 0. Greater than 0, it's actually equal to a number. It's set equal to a number. There's a couple ways you can do it. You could do it the way that the textbook shows you. But what I like to do actually is I like to just take the inequality and just set it equal to whatever the number it is and solve for all values of x. Now, first thing you would want to do is you want to say that, all right, if you get 3, it's not going to work. So automatically 3 is undefined. And it's an open circle. Now what you do is I like to just solve now. I'm going to cross multiply. X plus 1 is equal to 2x minus 6. And just solve. So bring the x over, bring the 6 over. It looks like you're going to get 7. X equals 7. That's your other potential root. Now 7 works. 7 is going to be a closed circle because of the less than or equal to symbol. And then you use test points. 0 is a good test point. 5 is a good test point for this area. And 8 is a good test point for this area. You plug in and it turns out you get negative. Now, a negative you shade because you want to, actually not necessarily, because you want to pick a number that's going to be less than or equal to 2. 1 will work. All right, so you'd pick, say you want to pick 0. Let's see what happens. Go back to the original. 1 over -3, which is a negative number. A negative is definitely going to be less than 2, so that's why this is shaded. You pick another number, like say 4. 4 plus 1 is 5. 4 minus 3 is 1. So 5 over 1 is 5. 5 is less than 2. That's not true. So that doesn't get shaded. Then you pick another number, you plug it in. If it's true, it gets shaded. And that's how I would do these last two problems. They're doing a little bit differently. I would set this equal. -4 would make this undefined, so that's why -4 is a possible root. Open circle. Set this equal to 0, and then you solve. So let's see what that would look like. So you have x squared plus 2x over x plus 4 is equal to 4 over 3. Now what I'm going to do is I'm going to cross multiply. 3x squared plus 6 is equal to 4x plus 16. Bring everything to one side. It looks like you have to factor. That's what you get on top here. You get 3x squared minus, looks like you have, this was x squared plus 2x. This is a 6x. Bring the 4x over to the other side. So you get 2x, positive 2x, and then minus 16. So it turned out the way I did is going to give you what you get on the numerator. Factor, you get negative. Factor, set it equal to 0, solve. You get -8 over 3, and you get 2. Pick the test points. If it's true, you shade it. If it's false, you don't shade it. That's really what you're going to do. Same thing with number 9. All right, guys, good job today. We're going to do the last startup tomorrow for tomorrow's lesson, which is to do a do now, do a family feud, go over lesson 14's homework, and then let you get on your way with the review pages. Now I will go over the review pages. That's another assignment. So I want you guys to try those first before I go over them. All right, so good job today, and we'll get going and we're gonna get ready for this test. It's coming up soon. All right, talk to you guys soon.